Now we can start the presentation. So good afternoon, and I would like to extend my thanks to the event organizer and to everyone that's here. So I am Taz, and this is Sylvain, my friend. We are both not from here, as you can tell. We're speaking English. We are from Canada, and we will be talking about detection engineering, and yeah, pretty much everything about it. So yeah, I'm Taz. I'm working currently at Microsoft. I am one of their security researchers in the cloud space. I am also part of the collective called the DFI Report. I think you probably know about it from Twitter, and also the curated Intel member. And Sylvain, you can introduce yourself.
Yeah, hey, good afternoon, guys. My name is Sylvain, or Sylvain, if you're francophone. I'm currently working as a security developer for an MDR company called Arctic Wolf. Yeah, so.
Yeah, so let's go. Next slide, please. Just some disclaimers. So anything that we say here is that doesn't represent of our employer views, and please use these contents as a guidance, not like ultimate thing to make everything works. It will not work. It's security overall. So yeah.
And nothing works out of the box right away, right? Yeah, so first I'll talk about detection engineering for organizations, right? So just understanding what, detection engineering is and what that looks like in an organization. Firstly there's, you got to create the detection, manage and improve it, work on the detections themselves, and of course work on the platform. But then ultimately, right, you'll see that it's all about building relations with your key stakeholders, right? Whether it's internal or external. Part of detection engineering could be a dedicated role, but we find that it's kind of expands from that, and it can include other roles like threat hunting or just security engineering as a whole. What are some requirements? Of course, there's many more, but these are some key ones. At the core of it, you need to rely on your subject matter experts. These are the people that are, key and vital to driving the operation, right? So they need to have environmental awareness. They need to have a good understanding with the logs and the data that they're working with, the platform, and have just organizational knowledge, whether it's you're building detection for your internal or just for whichever vertical you want to cover. They need to understand the risk and the threat awareness or the landscape. You need to have data, right? So you need to work with logs and telemetry. If you don't have that, then you're just imagining things. You need to have logs from all sorts of data sources. It's better if you're working with a data engineer that can, kind of massage it so that way you have something to work with that's very easy. And of course, ideally it's centralized using a platform such as a SIM. Transitioning to that, it's nice to have platform engineers or detection engineers to support this infrastructure. And then of course, you want to mature this process, have key stakeholder involvement, and of course have good relations with the people that are going to be using your detections, right? So that's your SOC or the MSSP or MDR teams that you have. Who are part of the detection engineering teams? There's the researchers, so that's who you initially think of, as the detection engineer. So your developers, your threat hunters, people that might work in DFIR, your threat intel analysts, the red teamers, your vulnerability management teams. But there's also of course the people that are receiving the alerts. So that's operations, so your internal SOC, the MDR, MSSP. You need people to support these. These are honestly the unsung heroes of the whole detection engineering kind of function. It's your engineers and the people that do logging, right? So without them, honestly, just if you meet them, give them a nice coffee and words of appreciation, just because they're the people that make it run. So yeah. Talking a little bit about the life cycle, Task is going to go over kind of these steps in a little bit more pragmatic or within an example.
I think for this particular one, it's specifically for organizations. So there's going to be different the perspective as if you are as a detection engineer, as we are, developer, researcher, whatever they call it. And this is from organization. If you want to implement detection engineering, this is probably the best way to do it based on experience. Well, we share so many experience, SOC, MSSP, MDR. So yeah,
Yeah, so, I mean, not all of these steps in here are like things that you do every single cycle, but, it's good to keep these in mind. So, of course, you need to have like a proper platform to work with. You need to have work within like a framework where everyone agrees on like the terminologies and such. Have like planning, do some data engineering and selecting like what data you want. And then do some research in terms of like what threats that you want to cover, right? Like, does it make sense to cover these threats for your organization and with the data that you have? You also want to select threats that are essentially relevant, right, to your vertical. Then you want to work on the implementation, testing. You want to select the appropriate detection mechanisms. We can talk about that a little bit later. And you also want to work on the documentation, right? So these are like how you triage it. What do you do when you get an alert? How do you respond to it? How do you respond to it if it's a false positive, right? Because you're going to have a lot of those. And some details on like the threats itself. What can they do? And yeah, just some additional details. Sorry, I missed. You also, this is a, it's a buzzword, but the CI/CD it is important. Like these detections, they are
What
alive.
is CI/CD?
But once you like send a detection into production, it's not done from there, right? Like you need to make sure that it's still relevant, that the metrics are good, like in terms of false positive to true positive. Also, you want to validate that you're getting some true positives, right? So that's like a very important thing. Yeah. Okay, so here we're going to talk about detection engineering for the individuals. So like what can you do to get involved, and maybe you don't even know it already, but you might be already involved. Yeah, this is I don't know if you made it up or...
It's my quote, yeah.
Okay, it's his quote. So master one or two, understand some, know the rest, right? When we say know the rest, it's like, at least like recognize the buzzwords and like have a good idea of like maybe which direction that's going into, right? You may not be an expert in it, but it's good to have the context. And that's kind of like what we feel like the modern day threat analyst is like. Like the good ones that we see, like they don't just stick to, responding to tickets and just doing like the pure security analyst work. They also maybe get involved in like the incident response aspect. They might do like their own threat intelligence to, see what's out there and understand like what they should be on the lookout for. Maybe they'll be more proactive and do some threat hunting, but also be engaged in the detection engineering pipeline and process.
Yeah, maybe a quick poll, like who's here from the blue team, SOC, MDR, MSSP? Put your hands up. So you probably see like this role, like it's the line is blur. Like one person do multiple of this, right? So that's kind of the idea of modern threat analyst. You're not like just managing ticket. You're doing pretty much everything and you gotta be ready for it. So yeah.
Yeah. So just to maybe focus on like three aspects, the threat, the data, and the detection. These are things that you want to keep in mind when you're getting involved in detection engineering. I don't know if it's clear for you guys, but this is just a sample job posting on LinkedIn for Uber.
This is a job posting from Uber a few days after they get breached. So a little bit too late, but it's a good job description. I use Uber all the time. I don't hate Uber or anything. Disclaimers. Yeah.
So like just to highlight the 3 points that we mentioned earlier, right? So one of them is they're looking for people that have knowledge or in-depth knowledge in the data, right? So whatever data sources that they might have a good understanding of like detection and detection mechanisms. We'll talk about that also afterwards. And of course, like have some familiarity with like the current threat landscape, right? So yeah, let's see. Okay, let's talk first about threats or TTPs and risks, right? So there's a lot of great resources out there. From our experience, we found that like the MITRE ATT&CK framework is probably like the gold standard right now. Like everyone speaks like MITRE or the TTP, so it's very easy to communicate with. But where you can learn about threats that might be more relevant to you is maybe from your previous incidents or breaches, or you could learn from other incidents and breaches that in your industry that are relevant to you. But yeah, so understanding the threat is knowing what to detect, right?
Yeah, I think to add to that, right? Sure, you can have like kernel exploitation on the wall on Linux, but you don't use Linux. Does that really matter to you? So it's like understanding what threat applies to you. If it's just the usual BEC phishing, it's still something that you want to look into more compared to some fancy exploitation. So just some notes on that.
Yeah, speaking of BC, so this is a email compromise, so email server compromise, just very high level, and the attacker is trying to exploit their their mailbox to deliver spam. Maybe just very quickly, just trying to like identify, maybe brainstorm on like what types of detections that you want. We'll probably ask you guys for some maybe suggestions or some ideas. And
yeah, so for example, you see somebody get phished in your organization. You want to know how they get phished, how they open the attachment, how they open the OneNote file or whatever, right? So you trace back through your logs, you check your email logs, where they come from, who's the sender, are they sending it to other people? So the idea is to understand the threat, is to explore. So incident response is a big part of it. For example, so you can look in the bigger picture and you determine, okay, this is the steps of attack, which is like pretty much like MITRE attack, the kill chain, but this is like, you have to tailor it to your needs.
Yeah. Okay. So maybe getting to more detail. So speaking of data and logs and telemetry, so we've identified kind of like maybe three types or three surfaces, if you will. So there's network, right? Those are like your firewalls and like, well, actually, I'll give you some examples later, but there's hosts and there's cloud. These are kind of like the three major areas of logs that you can look into. And understanding the data is really important because that's you need to know where you can detect a threat, right? So some examples for some network logs. So there's all sorts of appliances, so firewall, anti-DDoS, load balancer, router, and DNS, right? So NIDS, yeah. And for host or endpoint logs, there's like HIDS, EDR, AV logs, right? So one that's pretty popular is like Sysmon, OS Query, MDE, and you can also use EDR logs from your vendor of choice, right? But what's important about these logs is that it's host kind of like telemetry. So like you get process activity, that's really important, file activity, registry key activity, and sure they'll include some network activity as well. Then you'll also want some like host-specific logs. So like, yeah, so Windows have their own, maybe for like PowerShell and such, Linux, Mac OS if you have those. Yeah, so let's see. For cloud, yeah, so cloud is a little bit more new and it's a little bit more abstract.
Yeah, I can talk to it.
Yeah.
His side is like endpoint side, so don't blame him. So yeah, for the clouds, it's cloud is just like someone else's server, right? You don't have visibility to it. You just trust whatever logs they have. So just look into it. You can submit like if you need to know more information about it. But the main one that we use these days, like a lot of people use Azure AD, Okta, some other authentication application. So the logs will be as important as the on-premise AD. So we are talking about Kerber roasting. They can do Kerber roasting on the cloud. Not really Kerber roasting, but something else, like the Golden SAML and all those stuff. But it's kind of like similar. It's similar mentality, understanding those logs. And then user admin activity. Okay, who changed the user password? Who reset the password? Where, when, who, which IP address? And then for like Microsoft, they have like a cloud security solution. So like CASB or some other things. Like even also like DLP solution on the cloud. So those are things that you can also look into because if you're connecting all the dots of the attacks, you need to look from different perspective if you're able to. But you should start from one point. And then cloud apps, so the emails, what other tools?
Authentication, right?
Not authentication. It's more like the apps, like even Excel's, Words, SharePoint. If someone exfil file from SharePoint, you can see it on the log. So that's one thing that you want to pay attention. Again, it's almost the same. It's like kind of like endpoint, but on the cloud, I guess. And yeah.
Thank you. So yeah, so the detection, so these are kind of like the mechanisms for detecting the threat, right? So it depends on your data, depends on your tech stack, and how much resources you have. It can be simple or complex, right? You can just work with like basic IOCs, and you should at the very start at least. Then you want to move on to like working on detecting on like TTPs, right? And there's definitely different mechanisms for that, like correlation, some dashboards, thresholds, right? Using some ML, like algorithms and such. But yeah, so to understanding the detection, right? It's essentially to know how to detect it. So. Oh yeah, so back to this example. So any takers on some ideas on what we can detect?
If anyone has experience with cloud or anything, you see those steps, anything, nothing is fine. Going once, twice, third, let's go.
Right.
Yeah.
Sorry.
Yeah, it's another one, I guess. Oh yeah, it's actually me. Yeah, so for example, on the login, as I mentioned, just like on-premise AD, you can see like who's logging in, which IP. So here we can detect unusual login on Azure AD logs. Microsoft provided actually like alerts on that, but you can build on top of that too. If you have SIEM, you can actually ship the logs to your SIEM. You can make your own correlation. You can, like make a deny list on certain range of IP addresses. I don't know, maybe from OVH or from some countries. And then on the application side, malicious OAuth. So OAuth is like pretty much like the login things that they do. So they contact Microsoft, hey, is this user exists? Can I log into these apps? And then blah 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 blah. Yeah. So all of those activities, who's requesting tickets, etc., they have the log. So it's not easy things to do. I don't even understand about that. I'm working more on the email side on Microsoft. But if you have spent some time to explore that, will be a great detection, because if you stop it on the first one or on the second one, it doesn't really care about the rest, like, because they are stopped, right? Like you don't need to spend more resources on detecting the other stuff. So we get the third one is a creation of email connectors. So like application have a connectors, they call it. So it's a capability to do something on some other tools. In this particular example, so the application can send emails using Outlook. So if you identify an application creating that, and then you ask your admins, who did this? Is this our work? If not, then it's something fishy, and you can create detection there. You can stop it there if you're unable to stop it in the other two, or if one of your detection is broken. It's always the case. It's always broken. And then lastly, you can detect like unusual outbound from email logs. So doesn't have to be Outlook. Could be your Gmail, could be your own email system. But these are the places that you can actually play around with. And yeah, let's do like a walkthrough as a detection engineer. Like, what will you do while you are doing detection engineering? So there are 6 steps, pretty similar to the one in the organization sites. So here you'll do preparation. We'll talk about it more. We do threat research. So threat research, can be skipped really easy. There's like a lot of open source resource these days. Same with the detection research. So that can go fairly quick, and then your implementation is going to take the longest, especially if you have no platform at all. It's going to take some time to implement it, and then documentation and CI/CD, which is continuous improvement and continuous development. Yeah,
well, I would say for the threat research, like maybe not skip entirely, but like it's a good Kickstarter, right? Like you'll definitely want to leverage these open source tools or detection sets out there.
Yeah. So preparation. The idea of detection engineering is your detection have to be proven to catch those attacks, and also not catching everything else. So the best way is to have a lab environment, or maybe like a one machine in your network that you can play around with, and it has to be in a clean state. So there are no malware already running in there, changing the registry key and such. And then you make sure all your logging tools are capturing the activity. So for example, use Sysmon. and you check your SIM, you're not seeing sysmon logs. Don't even move forward anywhere. You just try to fix why the sysmon is not sending the logs. And then, from there you can decide which log you're going to use. Scoping is important, especially how long you want to scope the detection. What's our coverage? Is it the whole company? Is it one business unit? Especially if you're in the MSSP or like MDR consulting business, you might want to split it between different sets of companies. So there's a blog post by SpectreOps. It's really good on deciding how to prioritize the detection. So for this example, we're going to talk about how we are detecting or like how we are building detection for Infoshare Finder. If you don't know, Infoshare Finder is a tool that is allow you to explore different shares in the network. This is part of another tool. Powershell, yes. So you can see traces on network side, on host side. In this example, my organization, for example, we want to detect this. We are trying to cover discovery TTPs right now. So DFIR report, it's a website or like a team that shares different, traces of malware attacks. So I look up for Infoshare Finder in their repository, and I find at least 6 articles. So I guess this is pretty prominent threats for my organization. And I do threat research. What exactly happening when someone run the tools itself? So you need to know how to run it properly. You need to learn it. Sometimes you can even ask for some other team to run it, like the red teams, pen testers. And then you see the behaviors of the tools. What can you see from your logs? In this case, we're going to check the network and the host. And then what a successful operation looks like. Does it generate like a file? Does it alter something in the system? And and you can also do code review. So it's an open source tool. So you can see like what component of the tool itself. So in this share finder, so Infoshare Finder is part of the Powershell, which is a PowerShell based tools, or PowerView. So it's using PowerShell, and there's a log for PowerShell, and that's the first question that we're gonna ask. Like, okay, can we see anything from PowerShell? Based on the open source resource on the code, it has a alias called find domain share. So what if attacker, instead of typing Infoshare Finder, they type this? Is that within your scope or not? And the function is to enumerate file share. So this is I'm running the Infoshare Finder in the lab. So I can generate the TXT file with all the domains in there. It's just like making sure I run it properly. And then detection research, the goal is to detect the tools without introducing false positive or false negative. You need to decide the scope again, and then review the logs. So just keep going. I think it's just the same thing. So for example, for PowerShell, okay, there is a PowerShell logs. It's from Windows 4104, 4103. We'll talk about it on the next slide more. But on the DFIR report, the 6 articles that I mentioned, I see something interesting, that it's actually launched by Beacon. And when it's launched by Beacon, it's, has a combination with the IEX, which is like a PowerShell download function. So that might be something that we can do something about. And then 4104, 4103. So you can see, over there, up there, it's a long script block text. If you can see, it's 41 of 47. So normally you don't have that long script block text. So you might want to pay attention on that. And then, like Harmjoy, the creator of the tools, his name is literally there on the log. So if you see his tools in your logs, I don't think that's a good thing. So we can move forward. Another thing from the network side, we are seeing a lot of interesting from Sysmon even ID3. You can even see something from firewall or some other network tools. We are seeing some connection from port 389, which is LDAP, which is kind of makes sense. When you're enumerating shares, you probably gonna talk to the using LDAP protocol from PowerShell process. Is that a normal thing in your organization? Yes or no? It depends to you. But if it's not, it's something that you want to look into more. But the thing is, you can actually bypass all those things, research, because it's already there. For example, if you go to Sigma is like a repository for detection for a lot of platforms, Defender, Windows, Linux, Apple, and everything. And also there's like a timeline of attack, so you know like which action being used by the attacker. So yeah, for the Infoshare Finder itself, there's already a Sigma detection for it, so you can easily implement this into your platform. And then, yeah, for the PowerShell, the IEX, the download execute, it's already there also. If you implement it, it's probably also a good idea. And then on the implementation itself, this is the most important thing. Like, will you move those detection into a working state, right? So there are some free example out there. If you probably use, most of the security organization use these tools, either Elastic, Sentinel, or Splunk, and maybe some other SIEM like Carbon Black and such. But it's easily translatable, so you can pretty much convert it easily. But there's also like open source or like public, commonly used signature repository, such as Sigma, Yara. Yara is for like file, Snort, Suricata, or Zik. It's for network. And of course, you can make your own custom detection platform, but I don't recommend it because it's a pain in the ass to manage. Yeah, and then the key of implementation is actually validating that your alert works. So you need to run a simulation. So you deploy your detection. You need to trigger the detection. If it doesn't trigger, then your detection not work, or you're not using the tools the right way. So either way, both of them are bad. Well, we need to make sure that we're not doing that. So there's a lot of things that can go wrong, and as I mentioned earlier, everything goes wrong in security. So your logging problem, data schema problem, there's delay in data ingestion, somebody changed the network, diagram, and one of the network engineers changed it, you don't even know. And then, of course, host issue, like the user tried to disable the tools, it's not reachable or whatever reason. So it's always good to verify your detection. And documentation is something that is not everyone like it. Not everyone like doing documentation, but it is a good place to to store everything that you know about detection, because your detection engineer can leave at any time. Somebody offer them better money, they'll leave. Or maybe even your company tell you to fire your detection engineer, like these days, like there's a lot of layoffs and stuff. You never know. So it's always good to keep the knowledge. So you can have the database of detection. So, detection covering, cloud, covering host, etc. Just to ensure visibility, and you can use it as a metric for the executive. So we made this many, and we are covering more on the cloud, we are covering more on the host, more on the network, blah, blah, blah. And then for the details and query, I would personally recommend ADS, or the Sigma itself, because it contains some information. So there's 3 types of information. Can move to the next one. So contextual information. So it's information that give you context. So what is this attack? What is this detection? Why are we doing this? It's just giving the analyst or like whoever is responding to the alert more context. And then there's technical information, so like tools, like what is these tools, like how do you use it, what about the command how to run it, what about the detection itself, the code, and etc. And then there's support information such as blind spot. So for example, if you are excluding certain hosts, if you're excluding certain slice of your clients, you know why it's not firing, and there's like false positive. Okay, we know that this application is doing this also, but it's benign. So that's a good thing to know. And then CI/CD, aka the detection, is alive, because it is a continuous process. It's a detection life cycle. It's not just like you made it and then you sign it off and then you don't even look at it anymore. Yeah. And then, you need to continuously improve and develop the detection. So you need to review periodically, the volume of the alert, false positive, true positive, benign, true positive. So the alert fires, but it's actually one of your admin doing it. So I don't know, maybe they're using, was it Mimikatz or something? No. Empire, PowerShell Empire. There's admin using Empire to update machines in the network, which is like crazy.
Yeah,
like
just to elaborate on this story. So there's a network admin. He was using Empire to manage his endpoints because it was more reliable than whichever solution that was available to him. So
yeah, so it's like that things happen. So by reviewing your alerts, you know like what's going on inside. Performance on the platform. Does it make sense money wise to deploy one detection, for example, on the network, or is it cheaper if you deploy it on the host? So that's something that you can think about. And then even to alert time differences, delay, sometimes you collect the data now, you send it to the alert engine, and the alert comes the next day. Is it good enough? Are you able to tolerate that? And anything that is non-efficient, anything that is bad performing, you want to take it out, or you want to update it, or you want to add new function, you want to correlate it with some other stuff. You can do complete rework, or you can just like throw it to the bin because it's not working anymore. So if we check the open source, even the open source detection, they have that CI/CD. So you can see, okay, they create new rules. Okay, they update rules because the logic is wrong, and then they make big update. It's not clear what big update, but they change something. You can see on the code. So using tools like GitLab or GitHub, it's a good place for you to do CI/CD as intended, I guess. And then these are some resources that you can ponder upon. You can check it later. So open source detection, as I mentioned before, Sigma, Yara, and Snort. There's the link for that and what they are. Can move to the next slide. Again, the different, the popular, I would say, like SIEM or like tools. They have detection in there, so you can open the links later when you have the slides. This is just open source community. So OICD is, so if you would like to participate creating detection with random people in the world from random resources, but you should trust it. That's a place where you can do it. So it's not, let's say you can do it in your organization, but you want to do it, you can try to play with that. OTRF, it's more like bringing security from different backgrounds. So it's like vendor agnostic. So you get all the information about data. This is mainly data, like how to use the data. So like Windows logs, what are those? What is log event ID 1, 2, 3, blah, blah, blah. So they have it in there. So the link is there also. Organization that is doing great detection engineering, DFA report. Red Canary, they just released like a new threat detection report. Microsoft, SpectreOps. SpectreOps is really like, they're creating the fundamentals of detection engineering and threat hunting in general. So it's really great to follow. And then detection engineering repository, OSAM is like it's data. It's related to the data and logs. So they get I don't think they get samples, but it's more like data dictionary. So if you have any question about your data that you're seeing, your Linux, your Mac OS, your Windows, you can check that. Hopefully they have it. And yeah, there's some readings, some new readings, fairly new. I like actually the Zach Allen, like a weekly news. So he shares everything about detection engineering, different articles written by other folks, and it's just but everything else here is great. And some people that I talk personally. Really great people. If you want to follow them in Twitter, link will go to Twitter or LinkedIn. I'm not sure, but it will go somewhere. Yeah.
It's not malware, I promise.
So yeah, so that's pretty much our talk. It's rather fast. It's a big topic, but we go fast. We get 20 minutes for a question, like 10 minutes for a question, something like that. Yeah. Thank you so much, everyone.
Thank you.
I really appreciate it.
Thank you for this presentation. We will take a few questions. Somebody? Yes.
Does it work? Yeah. Thanks, guys. Good talk. Topic close to my heart because we are running a detection content team. A bit about the stakeholder management. How do you guys manage, let's say, conversations with the SOC team? How the feedback from the SOC helps you improving the detection?
Yeah, sure. I can take this one. So yeah, like it's very important to have a good relationship with your SOC team, right? Like, you need to be in their shoes and understand, like, you know, they need to understand, like, you're thinking on their behalf as well, like, in the sense of, you know, we're here to just catch, like, the true positives. We also don't want, like, the false positives. And it needs to come to, like, an agreement on, like, what is, like, a good true positive to noise ratio, making sure that, like, they have, like, a very seamless experience, right? Because they're always being flooded with tickets, and you need to really, like sympathize and empathize with that, right? So, making sure like your documentation is clear and that like it's as easy as possible. In terms of like how to do that, you know, definitely have them involved in the detection pipeline process. So like while you're tuning, you have the conversation with them and have some analysts see like, hey, these are some false positives that we've tuned down. This is the state of the rule now. Like, are we like in agreement that like this is a good state? Of course, like have them walk through the documentation with you and, you know, like that they're okay with it. But yeah, like the more that they're involved, you know, like the more that, it's less like of a burden that they're receiving and more that like, hey, this is something that like we want to have and that we've worked on together. Is that good? Or?
Yeah, thanks.
Yeah. Sorry, I just want to add something too. Like I've worked with good SOC. I've worked with bad SOC. Like, we send great alert. They don't respond to it. They just like say, yeah, we close it. Like, what'd you do? Yeah, we just close it. Like, they don't have understanding. So I think the most important part is to build that conversation with them. So you create a meeting with the managers. You let them know what coming to them, what detection coming. How do you respond to it? If something wrong, if something is bad, like how can they contact us? I think once that process is in there, it's just, you just need to going slowly together. And then eventually it will just run like that. So yeah, communication, I guess, like documentation, which not everybody loves to do, but it's still an important part.
Thanks a lot. Can I ask another one?
Hey, very good talk. What is, in your opinion, the best way to reduce the noise in the detections? For example, exclusion, risk. How is the best way, in your opinion or experience, to reduce the false positive and the noise in the detection? Some of them are super noisy, right? How are you dealing with, in your experience, in the best way?
Okay, I'll start and then I'll pass it to you. So, again, every organization, it's different. We have this, we call it like, false positive appetite. So, what is your appetite for false positive? Okay, I can take 70%. I work in an organization that take like 50%. So even it's bad, but they go through it. So first thing you need to know, if your client or your organization, what is your risk appetite? Once you know that, then you have to stick to that, I guess. Like you build high quality detection. So you have low confidence detection. Figure out a way how to make it higher. If it's, could be correlation, could be combining multiple detection. I think that's pretty popular these days. They call it observations. So like, okay, I get IP from China. 10 years ago, that's bad. Now, it's someone on vacation checking their email. And then you connect the dot. What are they doing after? Or they log on to email. What are they doing in email? Okay, they are sending an email. Okay, that should be fine. If they are creating Outlook rules to send any emails that come in to some other emails, that's suspicious. So you kind of like trace back okay, what's next can be done, or what before that can be done, and kind of combine it together. It might be hard if you don't have the right platform, but I guess to improve it, I think that's the best way to do it.
Yeah, maybe on like a more scalable kind of like mindset, like maybe like to Tas's point about like risk appetite, you kind of need to justify like the false positives, right? So like maybe having a good understanding of like what is like the severity of this detection or this threat that it's trying to detect. And you maybe can think of like a score for that, and then just like maintaining like a good ratio for that to justify the false positive. But also sometimes like you need to start like from the very start and think like, is this the right detection mechanism for it, right? Some detection mechanisms are a lot more noisy, like maybe like if you use thresholds, right? If you're working with like multi-tenant, like it doesn't make sense to have like a static number threshold because like if you use this for like a small organization, it'll never trigger if you've tuned it for like a large organization, right? So you need to really understand like the detection mechanisms that you're working with and those limitations, right? And that's kind of like I guess like the balance of, or the art of detection engineering. So, any other questions?
Yes. Thank you very much for a very interesting talk. You opened a whole new world for me. I have a background in web application firewalls where the appetite for false positive in an organization is extremely low. But you talk about detection. Do you ever get into a situation where you think your detection is now so good that you make it into a blocking rule for going forward? Or is that like unattainable based on your data?
At Microsoft, yes, we do have that kind of things. We call it, yes, blocking. Let's call it blocking. Response, something like that. So we know for sure they're bad. We block it. We don't talk about it too much here because that's kind of like active response store kind of thing. But if you have the infrastructure, fire alert, send it to the ticketing system send it to the store. That happened. That happened all the time in many organizations. For example, even if you're like logging in to certain, like to Azure AD, you logged in from different area, and then the Azure AD just doesn't like it, and then they block your connection or contact admin, something like that, right? So that's already there. It's already rolling. So if you able to do that, that's great because you don't need to worry about it. You just like stop it.
So that's generally a perspective you're kind of working towards. Yeah. Cool.
When possible, but not everything is possible, especially with machine learning stuff, right? You might want to double verify because they don't have context. They just know this looks bad, and then we alert on this. Also that's why we are not scared about our job, because the machine learning, AI, whatever you call, it's lacking that point. Like human can see it easily, but machine learning, sure, they can process a lot of data, but they will come to like some mistakes at some point.
Yeah, maybe a little bit more on that point. Like, I just see it as like an additional like mechanism or tool, right? It's not something that is here to like replace jobs, right? But, yeah.
Any other question? The last one, please. Yes.
Yeah, just a question from me. How do you practically manage testing of the detection use cases? Do you have some, I don't know, like scripts running that basically just try to break stuff, or do you just believe that it so will keep detecting? What's your approach?
Yeah, great question.
First, never believe.
Yeah, first, never believe, trust and verify, right? So yeah, like there are platforms to facilitate this, like purple teaming platforms. Of course, like you need to have like your endpoint logging or your logging mechanisms like on the tester machines that you have, and then ideally you have like a platform that already has like these threads that can just press a button and it'll run it. But if you don't have access to these tools, yeah, for sure, like building your own scripts. There's also like open source frameworks for this, right? Like from ART, yeah, like from Canary or RTA, yeah, Atomic Red Team and such. So there's a lot of like open source like tools that's available that you can run these scripts. Let's see, and yeah, for sure, like we'll run the detections ourselves. So there's actually like multiple tests that you should be doing. There's like what maybe we can call like unit testing or sanity checking. So like it could be like a modified or like dummy JSON file, and it's just gonna like periodically run through your pipeline just to hey, make sure that it's gonna alert on it and all the bells are working and such. But then there's also like real world attacker emulation. So like maybe you'll have like those tools that I mentioned, or yeah, like have like an external, maybe not external, but whichever like a purple team on your that can do real world emulation, right? So
yeah, I think just to kind of like conclude everything, it's like there's multiple steps, right? You crawl, you walk, you run. So you crawl, when you crawl, you can just start by having a machine, could be your own machine, just, well, not suggested to do that, but you can run certain tools in there and then make sure that the logs or like the detection, it's firing on the other end when you're doing that. The second one, you can also have your own lab that is having all the agents that you have, having the firewall on that side. So you do like full-blown activities in there and you can see if everything is working as fine. And then, yeah, for the running part, you can actually just get a vendor to do that, like install all the infrastructure. You can create your separate environment, like tenant-wise, and then like do everything in there. You can have the red teaming routine exercise. Yeah, it's just like how capable your organization is, I guess, the question now. And yeah, I think that's mainly how to do it. You can start small, you can go big. It depends on your organization. And there's a lot of services out there if you would like to pay. And there's like some open source if you like some free ones too. Yeah.
Cool. Thanks a lot.
So, thank you both for this presentation. You can applause.
Thanks, everyone.